So welcome to our new topic, Earth Space Science, looking at two internals in particular, the astronomical cycles internal and also the astronomical events internal. And today we're looking at the Sun and its relationship to and importance to life on Earth. So the first thing is, what is a star? So essentially a star is a giant ball of gas in space that releases light and heat into the universe. And the Sun is the closest star that we have here on Earth. And it's mainly made of two different elements, hydrogen and helium. And it has a diameter about 109 times larger than ours on Earth. So it's pretty big. And it's also very massive. It's about 333,000 times larger in terms of mass than us on Earth. So how does the Sun produce energy? It produces it through a process known as nuclear fusion. So nuclear fusion is basically where two small hydrogen atoms smash together under great pressure and temperature and form a larger helium atom, and it releases a lot of energy. I mean a lot. It's a massive amount of energy. And we're trying on Earth to try and replicate that to solve our own energy needs. But remember, in order to do that, that requires the high temperatures and high pressures which are found inside of stars. So how does it release or emit this energy? It uses it in the form, or releases it in the form of electromagnetic radiation. Okay, basically in the form of waves. And those waves have different lengths. Okay, and the only reason why it's in waves is because that's the kind of energy that is released into space, because space is a vacuum, there's no particles. So radiation is the only way energy can be transferred. You can't use conduction or convection because there's no particles to conduct or convect through. Okay, so a wavelength of this electromagnetic radiation is basically the distance between the peaks or the troughs of the waves, and the wavelengths can range from very big, which comes with radio waves, down to microwaves. Then we have infrared energy, which is your heat you sense, but it's actually electromagnetic radiation in the form of waves. Visible light, so that's your Roy G. Biv, your red, orange, yellow, blue, indigo, and violet. Then we move into the UV, which we have to be careful of here in New Zealand due to risk with skin cancer because it's getting higher energy. And then we have gamma rays and X-rays, which are the shortest wavelengths, which have the highest amount of energy. So most of the radiation that's emitted from the Sun is in the form of visible light, which we can, of course, see, and has a range of different colors, which we've just previously outlined. So what are some of the effects of our Sun's radiation on us on Earth? So luckily enough, it provides heat and light for life, for us to even live. It also drives the water cycles, the clouds, the wind, and pretty much how the weather and the climate exists on Earth. It also gives energy for plants to perform something very important called photosynthesis, which produces oxygen, which we use for respiration. We inhale into our lungs and use for respiration in our cells and the mitochondria, and also provides the food for animals because plants use the oxygen to create sugar or glucose, which animals can eat. And also, unfortunately, it can also cause, as we know in New Zealand, can cause damage to living cells, such as sunburn in the mild form, but long-term sunburn that can form melanoma and skin cancers, and also problems with the eyes. It can cause blindness. So also very important not to look into the Sun for that reason. Okay, so those are just some of the ways that the Sun affects our life here on Earth.